Okay, let's look at number 3. So number 3 is this. So again, we don't want to lose sight of our basic general 45, 45, 90 right triangle. So if you have some side length, the hypotenuse is the side length times root 2. Luckily, with number 3, we have the side length. So we know this is 9. Therefore, the other one is also 9. And that would mean that this hypotenuse is 9 root 2. So this would be nine root 2. So if that's 9 root 2, then so is this one. So we have this, right? We have this 45, 45, 90 right triangle. This one. So if that is 9 root 2, then this leg is 9 root 2, and then the hypotenuse would be whatever the legs are, whatever the value of the leg is. In this case, it's 9 root 2 times root 2. So it would be it would be 9 root 2 times root 2. So 9 root 2 root 2. Root 2 times root 2 is 2. So this would be 9 times 2. So x is 18. All right, let's look at number 5. Number 5, nice. So they've given us the hypotenuse involving a root 2. This is going to be easier. So we don't have to factor out a root 2 or anything. We already have it in this form. So think of your default 45, 45, 90 right triangle. If you have this side is something and this side is something, then this other side would be whatever that thing is, that side length times root 2. Okay. So this is the general case, side length, side length, side length times root 2. So we have the hypotenuse as 5 times root 2. So that would mean that the leg lengths must be, oops, come on, 5. So this is 5, sorry, this is 5 and this is 5. Does that make sense? Like 5, 5, 5 root 2, a root 2. So it's just recognizing and following this pattern. Okay, so that was easy. Or like the easier of the two cases. And then now we have a little bit of the harder case where you're given a hypotenuse as an integer. So it's not written as something times root 2. So we just have this with a 5. So we need to say, we need to express 5 as something times root 2. So 5 equals what times root 2? 5 over root 2, right? Because 5 over root 2 times root 2, the root 2 would cancel, and you'd be just left with 5. So let me just grab this from the other example, bring it over here. Okay, 1 second, so like this. Okay. we go. Okay, so 5 over root 2 times root 2 equals 5. So we factored out a root 2. So what times root 2 equals 5? 5 over root 2. So that must mean that the answer for this the side lengths are 5 over root 2. Right? Because now we had a 45, 45, 90 right triangle where that we knew the hypotenuse was something times root 2. That something was 5 over root 2. Therefore, the legs are 5 over root 2. And then we just need to simplify this so you wouldn't leave a radical in the denominator. So this would simplify to need to multiply by root 2 over root 2. So you're multiplying a fraction by 1, so anything times 1 is itself, so you're not changing the value of the fraction, you're just changing the form. And then this equals 5 root 2 over 2, because root 2 times root 2 is 2. So this would just be 5 root 2 over 2. So that would be your simplified answer. So your answer would be this. All right, so once again, multi-step problems, but for these 45, 45, 90, it's either going to be hopefully very simple where it's, you're given a leg, and then if you're given a leg, it's just this, whatever the leg is times root 2 for the hypotenuse. Or if you're given the hypotenuse in terms of something times root 2, it's also very simple because then it's the side lengths is whatever the multiplier on root 2 is for the hypotenuse, like how we started this problem. So we started with this problem with 5 root 2, so the side lengths are 5. But then the second step of the problem was a little bit trickier because that was the hypotenuse of this 45, 45, 90 right triangle. And then we had to factor out a root 2. So we had, once again, something times root 2. That something is the side lengths of this 45, 45, 90 right triangle, which is our answer for x. And we had to, then we had to simplify this, get this radical out of the denominator. Okay, so once again, kind of long video, but I think it takes longer, definitely takes longer to explain than it takes to actually do, especially once you get the hang of it. So hope that helped.